So in today's video, we're going to look at independent events. Independent events occur when two things are happening that are independent of each other, which means that the probability of one thing happening has no effect on the probability of the other thing happening. Okay? So it says in this first example that Olivia has 4 highlighters. 2 are yellow, 1 is orange, and 1 is blue. She chooses a highlighter at random. After she uses it, she immediately replaces it. What is the probability that she will use 2 yellow in a row? The fact that she replaces it is key in keeping this an independent event. Should she take one out and not replace it, when she goes to grab another yellow highlighter, the probability of it being yellow has now changed because there's only 3 highlighters to choose from instead of 4. Okay, so replacing it is important if it's an independent event. So we want the probability of choosing 2 yellow in a row. So if we look at all of the possible outcomes are that she could choose yellow, yellow, orange, or blue. And then on her second one, she could choose yellow, yellow, orange, or blue. So you could do this in a tree diagram, or you could make it up in a chart. The chart might be a little bit neater than this because it's a little bit messy. Orange or blue. And then blue could be yellow, yellow, orange, or blue. So we have altogether, there are 4 outcomes, 8 outcomes, 12 outcomes, 16 outcomes altogether. So the probability of yellow followed by yellow out of 16. I have these first 2 possibilities here, these first 2 possibilities here. So it is 4 out of 16 or 1/4. Okay? Likewise, if I want to do the probability of yellow followed by blue, I look at my combinations of yellow followed by blue, yellow, followed by blue. So there are 2 out of 16, or 1 out of 8. Another way of solving this same problem with these double events is that you can use multiplication if they're independent events. So the probability of getting yellow would be the probability of drawing yellow times the probability of getting another yellow. So my probability overall is 2 out of 4, or 1/2. And if I multiply that by 1/2, I got the 1/4 that I got when I solved it in the first place. Likewise, probability of yellow followed by blue would be the probability of getting a yellow is 1/2. Probability of getting a blue is 1/4. And when I multiply those together, get 1/8, same as I did when I made the tree diagram. So this is just, this multiplication way is a little bit easier way for us to solve these problems. The fundamental counting principle, or we call it the multiplicative principle, for independent events, if you're looking for the probability of A and B happening, you can multiply the probability of A times the probability of B. So for this next example, what is the probability of flipping heads with a fair coin and rolling an odd number with a fair die? So probability of heads and an odd number. So we take the probability of flipping heads times the probability of rolling an odd number. So for our coins, heads would be one of the 2 options. For probability of rolling an odd number, that would be 3 out of the 6 options, right? This is 3 out of 6, but we can reduce that to 1/2 as well. So the probability of doing both of those things at the same time would be 1/4. Okay, this one is a little bit more complicated than what it might seem at first. So if a fair die is rolled 3 times, then determine the probability that exactly 2 4s occur. So we can't just look at the probability of getting a 4, and then not a 4, because that's not the only way that that can happen. We could also get the probability that we didn't get a 4 the first time, and then we got a 4, and then we got a 4. Or there's also the probability that I got a 4, and then I didn't get a 4, and then I got a 4. So you have to look at all of those cases. So these are the different cases or the ways that this could happen. So the probability that I got a 4 would be 1 out of 6. Probability that I got a 4 the second time would be 1 out of 6. And the probability that I do not get a 4, there are 5 out of the 6 options that are not a 4. So I multiply those together. So altogether, I have 5 out of 216. When I do it this way, I start with not getting a 4, so 5 out of 6 options to not get a 4. Then to get a 4 would be 1 out of 6. And to get the next 4 would also be 1 out of 6. Multiplying all those together, again, 5 out of 216. Likewise, when I go to do the last one, probability that I roll a 4 is 1 out of 6, that I don't roll a 4 is 5 out of 6, and that I roll a 4 is 1 out of 6. Okay, so if you know that all of your probabilities are going to be the same, then you're just going to, you could just multiply them by 3, or you can add these all together to get the probability as 15 over 216. Okay. There's nobody here.
Oh, okay.
I was making the video. What's up?
It shows up pretty good?
I think so.
Yeah? Okay.
Well, yeah, my voice might be not quite, but this, I just screen capture this. Like it's screen capturing my screen on the computer, not videoing.
Not the projection.
That's what I do every day too. I'm in a Google Meet on that computer and on the computer there. So this one will have this to pick up the volume. This I'll just broadcast my screen and they'll see everything I write down while they hear me talking. You know, they may not see me talking.
Okay, tell me this, because, yeah, mine, okay, so.
I log into a Google Meet on both computers. Right. This one is hooked up to the projector.
There.
So I present this screen to the kids at home.
Okay. Oh, okay.
And that way it's clear, super clear, like they can see everything really well.
Okay, so I was presenting that screen, so I should be presenting this screen. Okay. I don't know why I was presenting. Okay. And then this.
This I just have hooked up for the volume, and then I can move it over to the board if I need to put something on the board.
No, hooked up. So you don't do volume out of here?
No, because I don't think it has a microphone.
But the camera
I could do that. Yes,
yeah, okay.
I could. But I keep it hooked to this one in case I want to move over to the board, and then I just
So the camera is hooked to
the Chromebook.
Okay. But you could
right now it's hooked. Right now it is hooked to that to do this.
Okay.
Yeah.
All right. But yeah. Okay. So I'm going to try the screen share from there instead of.
It's just clearer, right?
It was clear to that, but it's small to me, and then it's taken up that screen, and I like to walk with that so I can see who's in the Google.
Right. Yeah. So I can still see everybody on this one.
Right. I couldn't as soon as I screen share.
Right.
I screen share from there.
I mean, it still shows up big on this one, but I can see the kids on the side.
Yeah. That's the beauty. Okay.
Yeah.
Well, that was helpful information. I thought you were like doing overtime.
No. There's somebody actually listening to me right now. This
is
for tomorrow.
That missed and it's like, what?
Yeah.
Oh, so tomorrow we.
This is what the kids at home will watch tomorrow, like in the afternoon.
Okay.
Yeah. Oh no. Okay. Last example. Your chances of passing math is 0.75 and passing physics is 0.6. So determine the probability of passing both. So probability, math, and physics, we're going to multiply them together. So 0.75 times 0.6. So when I multiply those together, 0.75 times 0.6, 75, 5 times 0.6 is 0.45. Probability of passing math and not physics would be 0.75 for passing math. Non-physics would be 0.4, so it would be the complement. And we multiply those together. And then the probability of passing or failing both, so not passing math and not passing physics. Not passing math would be 25%. Not passing physics is 0.4. 0.1 when we multiply those together. And that's it. So you're multiplying as long as the events are independent of one another.